Hello everyone, my name is Keshav Jadhav, and in this video we will solve a numerical based around duct design using equal pressure drop method, or it is also called as equal friction loss method. This is the second numerical on equal pressure drop method. Link for first numerical is given in description of this video. So problem statement is like this. Air duct system is shown in figure. So this figure is given to us. Air enters at A with static pressure of 7.5 mm of water. So air enters at point A with static pressure of 7.5 mm of water. The branch BE is 15 meter long and delivers 120 cmm. So cmm means meter cube per minute. So branch BE delivers 120 meter cube per minute of air in a room. The branch CF is 22.5 meter long and delivers 140 cmm. This branch CF, it is 22.5 meter long and it delivers 140 meter cube per minute of air to the room. At the end D of main duct, the air delivered is 200 cmm. At this end D, volume flow rate is 200 meter cube per minute. Using friction chart and equal pressure drop method, determine the diameter and velocity pressure in length AB, BC, CD, branch BE and branch CF of duct sections. Consider friction losses only. So first we will write given data. Here it is given that air enters at A with static pressure of 7.5 mm of water. So we can write static pressure P suffix SA is equal to 7.5 mm of water. Now from given diagram we can write length of duct section AB is 30 meter, length of duct section BC 15 meter, length of duct section CD 30 meter, length of branch BE 15 meter and length of branch CF 22.5 meter. So we can write this given lengths. Then here volume flow rates are given. So we can write volume flow rate through this branch BE 120 meter cube per minute. Volume flow rate through this branch CF is equal to 140 meter cube per minute. So we can write QCF is equal to 140 meter cube per minute. And volume flow rate through this CD section is 200 meter cube per minute. So we can write QCD is equal to 200 meter cube per minute. So by using friction chart we have to calculate dimensions of this duct. So this is the friction chart. In this friction chart, on x-axis friction loss in mm of water per meter is given. On y-axis volume in meter cube per second is given. These are constant velocity lines and these are constant diameter lines. So to calculate values of diameter of circular duct, we should know two values out of three parameters. First is friction loss in mm of water per meter, second air volume in meter cube per second, and third velocity in meter per second. So out of these three parameters, if we know two parameters, then we can locate point on this graph and we can calculate diameter of circular duct. Remember, this friction chart is used only for circular duct. If numerical is based on rectangular duct, then we have to calculate equivalent diameter of circular duct for given rectangular duct. Now here in this numerical, static pressure at point A is given to us. So equal pressure drop method can be slightly modified. For main duct, that is A to D, we will consider equal friction loss, and for branch duct we will calculate static pressure at this point and at this point. Based on this static pressure we will calculate friction loss for this branch, and based on static pressure at this point we will calculate friction loss for this branch. So first we will calculate friction loss for main duct AD. According to Bernoulli's equation, for main duct total pressure at this point is equal to static pressure PSA plus velocity pressure, that is pressure due to the velocity of air passing through this AB duct. This total pressure at point A will be equal to pressure loss due to the friction in section AB plus pressure loss due to the friction in BC plus pressure loss in CD plus velocity pressure at exit D. In numerical, it is given that consider friction losses only. Therefore, velocity pressure we can neglect, and we can rewrite this equation as this PSA, that is static pressure at point A, is 7.5 mm of water, is equal to pressure loss due to the friction in section AB plus pressure loss due to the friction in section BC plus pressure loss due to the friction in section CD, which is equal to total pressure loss in main duct. Now, to calculate pressure loss per unit length, we will calculate total length of main duct. So, total length of main duct AD is equal to length AB plus length BC plus length CD. So, 30 plus 15 plus 30 is equal to 75 meter. So, this is length of main duct, and total pressure loss is equal to 7.5 mm of water. So, we can calculate pressure loss per unit length in main duct AD is equal to total pressure loss in main duct divided by total length of duct. So 7.5 divided by 75, we will get 0.1 mm of water column. This pressure loss we will consider same for this main duct, and we will calculate pressure loss due to the friction for branch duct separately. Now, to calculate dimensions for each section of main duct using friction chart, we have got value for x-axis, and on y-axis we have volume flow rates. Therefore, we will calculate volume flow rate for section AB, for section BC, and for section CD. So, total volume flowing through this section AB will be equal to volume of air in section BE plus volume of air flowing through section CF plus volume of air flowing through the section CD. So, total volume of air flowing through the section AB is equal to 460 meter cube per minute. We can convert this meter cube per minute into meter cube per second by dividing to this term by 60. So, we will get volume flow rate of air through section AB QAB is equal to 7.67 meter cube per second. Now, we will calculate volume flow rate of air through this section BC of main duct. Now, out of this total volume, 120 volume is going through this BE branch. So, in BC branch, total volume will be equal to this 140 plus 200, or we can calculate total volume of air flowing through this section BC is equal to total volume flowing through this AB section minus 120. So, it is equal to 340 meter cube per minute. And if we divide to this by 60, we will get 5.67 meter cube per second. Now, from this 340, which is volume flow rate through this BC section, if we subtract 140, then we will get volume flow rate of air through section CD is equal to 200 meter cube per minute. So, we can convert this 200 meter cube per minute into meter cube per second. If we divide to this term by 60, we will get 3.33 meter cube per second. In this way, we have got volume flow rate for each section of main duct. Also, we have calculated friction loss per meter length of main duct, which is equal to 0.1 mm of water. Now, we can use the friction chart to calculate dimensions of the main duct. So, this is the friction chart. On x-axis, it is friction loss in mm of water per meter, which is equal to 0.1. So, from friction chart, we can locate this 0.1. Here it is 0.1, which is friction loss in mm of water per meter length of duct. So, we can draw a vertical line from this point. Now, let us take section AB. For section AB, volume flow rate is 7.67 meter cube per second. So, this value we can locate on y-axis, because on y-axis it is air volume in meter cube per second. the 6.67 will be in between these two lines. So here at center of this 6 and 8 we will have line for 7, but here we have to locate 7.67, so it will be above midpoint of these two lines. So here we can draw a line for volume flow rate 7.67 meter cube per second. So this is the intersection point for section AB of the duct. Now these are constant diameter lines. So from this intersection point this line is passing. So this line is of constant diameter and its value is 950 mm. So we can write value of diameter for section AB is equal to 950 mm, which is equal to 0.95 meter. Now let us take section BC. So for section BC, volume flow rate is 5.67. So 5.67 will be below this 0.6. So we can draw a line for 5.67, and if you zoom in, then you can see line passing through the intersection point. It is having diameter 850 mm. So here it is 750, 800, here it is 850, and here it is 900. So this is 850. Therefore diameter of duct BC is equal to 850 mm, which is equal to 0.85 meter. Similarly for section CD, volume flow rate is 3.33 meter cube per second. So we can locate that point which will be just above this point 3. So we can draw horizontal line from this point. So this is line for CD section and this is the intersection point. So if you observe intersection point for CD section, then it is in between this 700 and 750. So we can take diameter of this duct CD as 725, that is midpoint of 700 and 750. Therefore diameter of duct CD is equal to 725 mm, which is equal to 0.725 meter. So in this way, by using friction chart, we can calculate dimensions of each branch, dimensions for each branch of main duct. Now as static pressure at point A is given in the numerical, we will separately calculate friction loss per meter length for these branch ducts. So for branch ducts B, A and CF, we will calculate static pressure at this point. So static pressure at this point P suffix SB is equal to static pressure at point A minus pressure loss due to the friction in duct AB. Similarly, static pressure at this point is equal to P suffix SC, that is static pressure at point C, is equal to static pressure at point A, that is PSA, minus pressure loss due to the friction in duct AB minus pressure loss due to the friction in section BC. So we will calculate pressure loss in section AB and BC of the main duct. So to calculate pressure loss due to the friction in section AB, we have pressure loss per meter length of duct into length of that duct. Length of this duct AB is equal to 30 meter and frictional pressure loss per unit length is equal to 0.1 mm of water. So pressure loss due to the friction in section AB is equal to 0.1 into 30, which is equal to 3 mm of water. Similarly, pressure loss due to the friction in section BC is equal to 0.1 into length of that duct 15 meter. So pressure loss is equal to 1.5 mm of water. Similarly, to calculate pressure loss due to the friction in section CD of main duct, that is pressure loss per unit length 0.1 into length of that duct 30 meter is equal to 3 mm of water. Now by using these values, we can calculate static pressure at point B and static pressure at point C. So static pressure at point B, PSB, is equal to PSA, that is static pressure at point A is 7.5, it is given, minus pressure loss due to the friction in section AB, that is 3. So it is equal to 4.5 mm of water. So this is the static pressure at point B. And static pressure at point C we can calculate by using this formula. So here PSC is equal to 7.5, that is static pressure at point A, minus 3, that is pressure loss due to the friction in section AB, which is calculated here, minus pressure loss due to the friction in section BC, which is equal to 1.5 mm of water. So if we calculate this, we will get 3 mm of water. So based on these static pressures at point B and at point C, we will calculate pressure drop required per meter length of the duct. So this is the static pressure, and this static pressure is equal to pressure loss in the branch BE, and this PSC, it is the static pressure at point C, which is equal to 3 mm of water. Therefore pressure loss in duct CF is equal to 3 mm of water. So we will calculate pressure drop required per meter length for this branch BE and branch CF. Here length BE is equal to 15 meter and length CF is equal to 22.5 meter. Therefore pressure loss due to friction per meter length of duct can be calculated for branch BE is equal to 4.5, that is total pressure loss in duct BE divided by length of duct 15 meter, which is equal to 0.3 mm of water. Similarly, we can calculate for branch CF. So total pressure loss in branch CF is equal to 3 mm of water. Therefore pressure loss due to friction per meter length of duct is equal to total pressure loss divided by length of that duct, which is equal to 0.133 mm of water. Now we have two parameter values for both the branch. Therefore we can use friction chart now. So from friction chart for branch BE, we have pressure loss due to the friction per meter length of duct is equal to 0.3 mm of water. So we can locate that point, which is here, and we can draw one vertical line from that point, and value of air volume flow rate in meter cube per second for the section BE is equal to 2 meter cube per second. So here it is 2 meter cube per second. We can draw horizontal line from this, and at intersection we can see here this line having diameter 500 mm. So we can write diameter of branch BE is equal to 500 mm, which is equal to 0.5 meter. Similarly for section BE, friction loss per meter length of duct is equal to 0.133 mm of water. So this point will be in between 0.1 and 0.2. If we draw at midpoint, it will be 1.5. So we will draw slightly on left side. So this is line for 0.133, and volume flow rate for branch CF is equal to 2.33 meter cube per second. So here it is 2 and this is 3. So this 2.33 will be in between these two. If you take midpoint of these two lines, then here we will get 2.5. So we will draw a line slightly at lower side. So this is the line for volume flow rate 2.33. So we can see here at intersection this line is passing. So this line having diameter 600 mm. So diameter of branch CF is equal to 600 mm, which is equal to 0.6 meter. So in this way we can calculate diameter of, dimensions of circular duct for each section of main duct and branch ducts. Now in numerical it is asked to determine diameter and velocity pressure. So we have calculated diameters. Now we have to calculate velocity pressure. So to calculate velocity pressure, first we will prepare a table. So in this table, first column is duct sections, second diameter of the duct in meter, third column it is cross section area of the duct. So cross section area we can calculate by using this cross section area A is equal to pi by 4 d square, where d is the diameter of the duct. So for each section of the duct we can calculate cross section area. Then in next column we can write volume flow rate in meter cube per second. So these are the values of volume flow rate of air through each section of the duct. Now we can calculate value of velocity of air flowing through the ducts. So to calculate velocity we can use V is equal to volume flow rate divided by cross section area. So here we have values of volume flow rate, and here it is values for respective cross section area. So this Q divided by cross section area, we will get velocity in meter per second, and as asked in numerical, we can calculate velocity pressure PV in mm of water column. So we have formula PV is equal to V divided by 4.04 bracket square. Here in this formula, this V should be in meter per second. If V is given in meter per minute, then at denominator it is 4.04 into 60. So here, as we have calculated velocity in meter per second, we will use V divided by 4.04 bracket square. So by putting value of velocity, we can calculate velocity pressure PV for each section of the duct. Thank you.